All right, here's your hint for 6.2, number 1. So we have our pedals up here turning this back wheel of our bicycle. So we want to figure out how many RPMs do we need over here to make that spin at a certain number of RPMs. Okay, so we know the omega value over here. Now, if it makes you feel comfortable, go ahead and get that omega value into radians per second. Now, whenever you have two objects that are connected, all of the points on that object have the same omega. So the omega of the big wheel is the same as the omega of the sprocket at the center. They all turn together. Okay? And then the thing connecting them, the chain is moving at the same speed all along the chain. So these two wheels share a common linear speed. Okay? So when we look at the relationship between angular velocity and that linear speed, or that tangential velocity, we are going to connect them using the radius, and this is the radius at which this speed is taken into account. So for instance, here we're looking at the speed of the chain, which is at a radius r, the radius of that little sprocket. Over here, we're looking at the speed at the radius of our larger sprocket on the front. And so what we find out is that because these have the same speed v, which is equal to the angular velocity of our big wheel times the connecting radius, and is also equal to the angular velocity of our pedals and its radius, we should be able to plug in our information and solve for that omega. So if you did convert to radians per second, you'll get your value here in meters per second, and then you can convert to omega. Otherwise, what you can do is you can just kind of set omega r equal to omega r and solve. And that's the strategy we're going to actually need in the next problem.